Hello friends, today we are going to discuss about one of the important topic in system physiology about muscle contraction. Muscle contraction. For convenience, we will be discussing about muscle contraction in two parts. In part 1, we will discuss about structure of muscle fiber and contractile proteins. In another part, we will be discussing about muscle contraction theory, that means sliding filament theory. Okay, we all knew that cells exhibit different kind of movements in multicellular animals. Say for instance, amoeboid movement, say ciliary movement, muscular movement. Say amoeboid movements, particularly the specialized cells like macrophages and leukocytes exhibit through pseudopodia. There are ciliary movements like internal tubular systems, say for example the way of respiratory tract or genital ducts, even the ventricles of brain, which have ciliated epithelium, they exhibit ciliated epithelial movements. Whereas muscular movements, say limb movement, the jaw movement, for instance, they exhibit muscular movements. The crux point for muscular movement is contraction. Why muscular movement is very important? Because here the muscles exhibit muscular movements and they serve as a primary component or organ for locomotion and other important movements. Say for example body postures, so I move my limbs, or I move my head and jaws, and all these are different muscular movements and they are served as a primary movements, that means locomotor movements, wherein skeletal muscle are the essential primary locomotor component. We all know that regarding the basics, muscles coming from mesoderm, origin from mesoderm, and they occupy 40 to 50% of the body weight. Okay, and here, since the skeletal muscles they serve as a primary locomotor components, we'll be discussing about skeletal muscle. As we discussed, we have discussed the muscle fiber and contractile proteins. What makes this muscle as a primary or the crux point for locomotion? Their contraction ability, what we call contractile nature. In general, muscles have three kinds of property, excitability, contractility, and relaxation. The contraction we call contractile property of muscle is a crux point for helping to act as locomotory components. Actually, muscles have three kinds of properties. Excitability, contractility, then relaxation. The three important features of a skeletal muscle, particularly this is very important now. Skeletal muscle, this excitability, contractility, and relaxation serve as something which makes the muscle as a primary locomotor component. See, the contractile property is most important, which is the main channel through which different component, that means different locomotor movements arise. Okay, but then since we have discussed about skeletal muscle, we will be discussing about different the structural aspect of skeletal muscle. Before going to the a detailed diagram, we are discussing about the certain basic issues of a skeletal muscle structure. Skeletal muscle, the basic aspects of skeletal muscle in the way of bundle. That means the skeletal muscle consists of different bundles, mostly called fascicle muscular bundles, which are adhered by means of fascia. By means of fascia is nothing but a collagenous protein component. This collagenous protein component, what we call fascia, which adhere different muscle bundle, what we call fascicles. Just imagine we hold together. That means with the help of a rope, with respect to a pile of things or a group of sticks. That means your fascia are like that. That means it is a collagenous substance which adhere the fascicles, what we call muscle bundles. And each muscle bundles consists of muscle fibers. And these muscle fibers, what we call sacrocyte. Just like the cell, here the muscle fibers as a basic component. That means here the organized structure of a skeletal muscle in the way of muscle bundles, and its basic component is in the way of muscle fibers. And this muscle fiber, the crux point, that means the essential component of muscle fiber is myofibrils or myofilaments. We will be discussing about contraction. We have discussed about the contraction nature of muscles makes muscles as a primary locomotor components. Here contraction actually with respect to the contraction of the myofibrils. Actually, strictly speaking, contraction of sarcomere, an integral component of myofibril, leads to muscle contraction. It is not exactly the contraction of myofibril, but contraction of the sarcomere, which is the internal or integral part of the myofibril, serve as a basic point for contraction. Okay. See, just take a a particular example. Say for example, this skeletal muscle. A rough sketch, and this skeletal muscle. Different components are there. We have already discussed. They are called fascicles. Fascicles. That means muscular bundles. Muscular bundles adhered by means of fascia. Fascia. A collagenous substance which adhere them. A collagenous substance. Okay. And these muscle bundles, say, I would like to magnify the same. Muscle bundle, say this muscle bundle consists of muscle fibers. Say, I would like to magnify the same as, muscle fiber. This is one particular muscle fiber. This is muscle bundle, one muscle bundle, and this is muscle fiber. Muscle fiber. When we understand, that means when we examine the ultrastructure of muscle fiber, there are different essential components. Say this is muscle fiber now. What we call sacrocyte. And this muscle fiber consists of the terminology will be different. We'll be discussing, we have discussed about plasma membrane, cytoplasm, like that. The same words, but the concept is same, but the terminology is different. Here, say for example, I would like to magnify the same. Say this particular thing. Say this is sarcoplasm. Sarcoplasm actually means cytoplasm. It is sarcolemma. That means plasma membrane. Sarcolemma. The most important feature of this muscle fiber is here the sarcolemma, what we call plasma membrane, will be invaginating. That means in the form of a triangle, that means transverse T-tubule forming a triad system. We will be discussing what exactly it is. Okay. Then this invaginate to form a triad system. They are nothing but transverse tubule, simply called T-tubule. Transverse tubule. We have all discussed here the essential component of muscle fiber is myofibril. Myofibril. How this end says this is particular, say this one particular component of myofibril. Another component, Here the sarcoplasmic reticulum, what exactly called, will be extending into the A band and T band. The endoplasmic reticulum, here it is called sarcoplasmic reticulum. The most important feature is endoplasmic reticulum, here it is called sarcoplasmic reticulum. The terminal cisternae of sarcoplasmic reticulum is important because they store the calcium ion, and this calcium ion serve as important, fundamental tool or basic tools for muscle contraction. We will discuss about it. Say here, this is called sarcoplasmic reticulum. Sarcoplasmic reticulum. Then, already discussed the most important component, the T-tubule. The T-tubule. And the cisternae of sarcoplasmic reticulum and the T-tubule together form triad system. Triad system. And these are the myofibrils. These are the myofibrils or myofilaments. And we will be discussing about this myofibril particularly. Say this myofibril, just want to draw a particular thing, consists of two alternate bands of light and dark bands, of light and dark bands, light and dark bands. Light bands are otherwise called thin filaments or actin filaments. Dark bands are called myosin. This is myosin. Okay, and this is Z line. H lines. This is a one particular way I want to discuss about sarcomere. You know, I will tell you what exactly is called sarcomere. This is A band. A band. This is I band. This is I band. Then this is the central point. This is called Z line. And this the central component is called H disc. H disc. And the whole this is a sarcomere. Okay. What exactly what I meant to say is, you know, we have discussed already. The muscle fiber sarcocyte is a fundamental tool of a muscle, say skeletal muscle. Because here, when we examine the ultrastructure of a muscle fiber, say for example here, the terminology is different. We have already discussed. Sarcolemma, nothing but plasma membrane. Sarcoplasm, nothing but cytoplasm. Sarcoplasmic reticulum, say endoplasmic reticulum. Sarcosome, say mitochondria. The unique feature of muscle fiber is presence of parallelly arranged tubules. They are called myofibrils or myofibrils. This is very important. Presence of parallel arranged tubules in the sarcoplasm called myofibril or myofilament is a distinct feature of muscle fiber. And entire muscle contraction depends on this myofibril. What exactly? And what are the components present in myofibril? So this is myofibril. When we examine the myofibril, it is nothing but it consists of two components between the alternate light and dark bands. You know, light and dark band. The light bands, otherwise called I bands. Here I means isotropic bands. Whereas dark bands, otherwise called A bands, you know, anisotropic band. The light bands, isotropic, contains actin as a chief component, the chief protein substance. Anisotropic bands contains myosin. You know, we already discussed contractile properties. We will discuss about contractile properties in detail, but first let us examine the basic ultrastructure of a myofibril. The myofibril consists of alternate light and dark bands, and light bands otherwise called I bands, that means isotropic bands, whereas dark bands otherwise called anisotropic bands. You know, what are these bands? They are nothing but the arrangement of proteins. That's it. Say actin, say myosin. Actin is a protein, but actually they are filamentous proteins. Actin, say for example, one actin protein consists of two helically arranged actin molecules in the form of helical fashion. Whereas the same case of myosin as well. That means they are polymerized protein substances. Whereas here the monomolecular unit of actin is called actin molecule. Whereas it is in case of myosin because meromyosin. We'll be discussing about. That means here the myofibril is nothing but it consists of alternate light and dark bands. That means I bands and A bands. I band consists of actin majorly. Apart from actin, it also contains troponin and tropomyosin. Whereas A band contains myosin. Okay, and here the I bands. Say for example here the I bands. On the center of the I band there will be a line called Z line or crosses membrane. Or otherwise called, you know, Dobie's line. That means the thin filament, what we call actin filaments, they held together by means of Z line. That means it's up because of its appearance called Z line, otherwise called crassus membrane, otherwise called Dobie's line. The same in case of, you know, just like I band, in case of A band, the central part, the central thin membrane is called M line. M line means here the myosin filaments in case of the A band, or what we call anisotropic or dark band, they held together to M line. Where the most important thing is, so this is I band and this is the A band. That means actin and myosin. We will be discussing about actin versus myosin aspects along with the regulatory contractile proteins like troponin and tropomyosin. That means the entire crux point of muscle contraction relies on this particular concept. And what is sarcomere? Here the thing is, we are discussing about, I band, the center is Z line, The zone between the two successive Z lines is called sarcomere. This is a fundamental zone for contraction. The zone between the successive Z lines is called sarcomere. And say for example here the I band, the edges of the I band, the partially overlaps the free ends of the A bands, I mean myosin filaments, so that the one particular component will be too much dark, whereas the central part, that means the center of the A band will be lighter in nature, what we call H disc, forming H disc or Hansen's disc. This is very important. So there are sub-components, terminology you have to remember for better understanding. So in I band will be central line called Z line, in A band will be M line, and the successive, that means the zone between two successive Z lines, otherwise called Crassus membrane or Dobbe's line, is called sarcomere. And whereas in case of A band, the ends are partially overlapped by the I band, whereas its center it doesn't contain I band, what we call thin filaments. That means that the center part of the A band which doesn't contain thin filaments is called H disc, or otherwise called Hansen's disc. So there are total different components involving in a sarcomere. Say I band, A band, center of the A band Z line, center of the A band M line, and its space is called less dark space, what we call H disc or Hansen's disc, where there are no thin filaments. No thin filaments. No thin filaments. And the successive, that means the space between the successive Z lines is called sarcomere. So this is about the basic structure of a myofibril, myofibril is some myofilaments. So this is about the overall anatomy of a muscle fiber. Next, the second subcomponent of this is structure of contractile proteins. We have already discussed. Just like actin versus myosin, that means along with the regulatory protein, troponin and tropomyosin, these all aids in muscle contraction. Okay, we will be discussing about the contractile protein. This is about the basic structure of muscle fiber and its issues. Okay. Then structure of contractile proteins. This is very important topic. Contractile proteins. Contractile proteins. Say here we already discussed thin filaments and thick filaments. Thin means here I band, here A band. The thin majorly it contains actin. Along with that it also contains troponin and tropomyosin. Troponin are different types like TNC, TNT and TNI. Tropomyosin single. A thick filament majorly contains myosin. So these are different components. Actin and myosin are major important protein, whereas troponin and tropomyosin along with subcomponents of troponin are known as regulatory proteins. Say actin. Actin we already discussed. That means actin is a filamentous protein, consists of two chains of helically arranged actin molecules. Say for example, what exactly I mean to say is, say this is actin. Two chains of actin, no? The globular proteins, they are known as actins. This is one actin, so there are two helically, that means two helicals, simply called, and they are actin molecules. This is actin. Okay, then these are all under the integral components of thin filaments, that means I band. Apart from actin, the associated protein, what we call regulatory proteins, say the tropomyosin. These are the filamentous protein. No? It also run close to the actin. This is called tropomyosin. Then another T and troponin, that means there are three important components, TNC, TNT and TNI. Say this is they attach with, that means associated with tropomyosin. I will tell you what exactly is. Okay, this is troponin, TNT and This is T and I. Then this is T and C. Regarding myosin is a bit different. It consists of a globular head, a short arm called neck, and a tail. I am just drawing one particular myosin, okay? Then again it consists of different binding sites called ATP binding site. Then this is actin binding site. So this is a myosin, ATP binding site. This is actin binding site. This is the head part, globular head. This is called short arm, what we call neck, and this is tail. That means this is actually the myosin is a polymerized protein substance, protein molecule, and the monomer, that means monomer molecules are considered as meromyosins. Here the thing is, in case of head and short arm, what we call neck, they are known as heavy meromyosin, HMM. That means heavy meromyosins. Plus tail consists of LMM. That means light meromyosin. Here cross arm, what we call, say for example this is another myosin head, cross arm. Say this is cross arm, for better understanding. This is another myosin. This is called cross arm. Cross arm. Here, these are the anatomical features of different contractile proteins, and we'll be discussing about the role, what exactly they serve. In for the thin filaments, or what we call the I band, the basic component of thin filaments or I band is actin. Actin is a filamentous protein consists of two chains of helically arranged actin molecules. That means the monomer is called globular actin. This is called globular actin. Okay. Then associating with actin, there are certain regulatory proteins. Regulatory protein means they mask or unmask the active sites of actin. Say for example, say this is a mask or unmasking role. Unmasking or masking role. This is called regulatory role of protein. But what we call regulatory proteins. What exactly masking and unmasking? In muscle contraction, the head, that means the actin binding site present in myosin head, will be attaching, that means by means of cross bridge with that of the active site of the actin. But in case of during relaxation, the same will be blocked by regulatory proteins. And what are they? Say the troponin and tropomyosin. They act in a coordinated manner. So the troponin, there are different subcomponents, TNC, TNT, and TNI. Tropomyosin. Tropomyosin is a black, see this black color. It's also a filamentous protein only. They are close to the actin, and each actin is called F. That means filamentous actin, F actin. Okay, simply it's called F actin. F actin. Whereas associating with tropomyosin, the three subcomponents of troponin we call TNC, TNT, and TNI. TNC, troponin C. That means it attaches to calcium. That is why the word TNC. TNT, here TNT associates with TNT, it will bind with tropomyosin. Whereas TNI, I means inhibit. What exactly it inhibits? It inhibits the active site of actin. So TNI and TNC. TNT is very important. When actually it binds to tropomyosin. Here TNC, when there is no calcium ion. When they say, for example, there are no, that means TNC means it binds to calcium. Say when there is no calcium ion, and this TNC will play important role in stabilizing role. What we call stabilizing means, say this is tropomyosin. It blocks the active sites of actin. When there is no calcium ion, this TNC stabilizes the blocking ability of tropomyosin. When there is a calcium ion, it will release. That means it will bind to the calcium ion, so that the tropomyosin and troponin, they pull off. Say that they are just like masking. What exactly they mask? They mask the active sites of actin. Say masking by the tropomyosin, TNC, TNT, TNI. When there is a calcium ion, this TNC binds to that, so that the rest of the tropomyosin troponin will be pulled off, exposing the active sites of actin for binding to the actin binding site present in the head, globular head of the myosin of the thick filaments or A band. This is the connection. Say when there is no calcium ion, this TNC will be act as a stabilizing role, so that the tropomyosin will act as a blocking component of the active sites of actin. But when there is a calcium ion, it just binds to the calcium ion, so that the tropomyosin and different components of troponin, that means troponin T, troponin C and troponin I will be pulled off, so that exposing the active sites of actin, so that the myosin head, which consists of active site for actin, say this is it, will binds to the active site, forming cross bridge. We will be discussing about in muscle contraction. So this is about how they different roles. So regarding myosin, it consists of two components actually, head and a tail. Here the head and tail connected by short arm, what we call neck. Here we all discussed, it consists of a monomer, what we call myromyosin. Head and short arm consisting of heavy myromyosin, so we call HMM, whereas tail consisting of light myromyosin, what we call LMM. And this thick filament, consists of some 200 to 300 myosin molecules. The thing is, half of them are orienting towards one Z line. We all discussed now. The joint between successive Z line is called sarcomere. The contraction of sarcomere is a muscle contraction. Okay, we'll be discussing about later. Okay, here half of the out of 200 to 300 myosin molecules present in thick filaments, half of them face toward one Z line or process membrane, and the rest of the half facing another membrane. That means opposite, another Z line. Here, so that the tails are facing towards M line, the center of the, we already discussed, just like the Z line in case of A band, in case of A band there is a M line. All this cell facing the M line. So these are all the coordinated activity of troponin, that means actin, troponin, tropomyosin with myosin, leads to muscle contraction. The fundamental, the crux point for muscle contraction is already discussed, sarcomere. That means the space between successive Z lines in a myofibril or myofibril is sarcomere. This contraction is muscle contraction, and for that these elements, that means troponin, that means present in thin and thick filament, that means myosin in case of thick, and actin along with troponin, thin will play an important role. Okay, this is about the structural dynamics of muscle fiber and different contractile proteins. In the next part we will be discussing about muscle fiber. Thanks for watching.